This is computer I want, but there is big catch, it costs $2K. So why instead of overspending on this, why don't I try to build my own computer from scratch with budget only $100? But what I would need and how to actually build it, well, building a whole computer at once would be complicated, so I will split it into these parts. We will start with core components. Computer at its absolute core is just a machine that manipulates electricity to do math and remember the results. Every piece of software is just a list of math instructions. To build a physical engine that can execute those instructions, we need to start with a transistor. A transistor is just a microscopic electronic switch. It has no moving parts, and when you let electricity into one side of it, it either allows current to flow through the other side or it blocks it. By mapping the on state to the number 1 and the off state to the number 0, we can use electricity to count in binary. I would buy a massive bag of cheap individual transistors, pull out a plastic breadboard, and start connecting them by hand using tiny copper jumper wires to build our very first logic gates. This should cost around $20. With transistors, we can move to the next step, which is building the CPU. This is the brain of the machine. To build a CPU on a breadboard, we have to arrange our transistors into patterns called logic gates. For example, if I connect two transistors in a straight line, electricity can only pass through if switch A and switch B are both closed. This creates an AND gate. If I connect them side by side, current can flow if either switch A or switch B is closed, creating an OR gate. By cleverly combining these tiny electrical gates together, we can build a physical circuit called an adder. An adder is a magnificent piece because when you feed two separate electrical binary numbers into one side, the physics of the pathways forces the correct mathematical answer to pop out of the other side. To make this a real CPU, we need to build an arithmetic logic unit, or an ALU, which is just a collection of these adding and subtracting circuits. Next, we need a way to tell the ALU what to do. We do this by building a control unit using more logic gates. The control unit reads a steady pulse of electricity from a basic timing chip, which costs around $5, and it acts like the heartbeat of our computer. With every single heartbeat, the control unit fetches a binary instruction from our memory, decodes which logic gates need to open, and forces the ALU to execute the math. We are building in 4-bit CPU, meaning it can only handle numbers up to 15 at a time, but the logic is exactly identical to the chips inside modern smartphones. It is just scaled down. However, because CPU is completely useless if it can't remember what it is working, we will move to the next step, which is building memory. The CPU needs a place to store its data and its list of instructions. In a modern computer, engineers use lightning-fast solid-state drives, or SSDs, which use incredibly complex flash memory. But buying high-end SSD chips is completely out of the budget. They are way too expensive, and they are impossible to create by hand. Instead, we have to get creative and look at how older computers solve this storage using magnetism. I would choose to build a basic hard disk drive, or HDD system, using a cheap, rotating magnetic platter. Even though I would probably end up buying it anyway because there is no way I could build it from scratch, here is how it works. To build on budget storage, we can use an old, broken vinyl record player, or a small electric motor to spin a metallic disc at a constant speed. Right above the spinning disc, we place a tiny electromagnet made by wrapping copper wire around a small piece of iron. When our CPU wants to save a piece of data, it sends an electrical pulse to the electromagnet, which creates a tiny magnetic field and permanently magnetizes a microscopic spot on the spinning disc. If the spot is magnetized pointing north, it represents a 1. If it points south, it represents a 0. To read the data back, the disc spins under the coil again, and the moving magnetic spots generate a tiny electrical current in the wire, sending the 0s and 1s straight back to the CPU. It would be slow, and I'm not even sure if it would work properly, but it gives us massive amounts of functional storage space for virtually $0. For short-term memory, like storing the exact number the CPU is calculating right now, we can connect a few transistors together into a looping pattern called a flip-flop circuit, which can hold a single bit of data as long as the power stays turned on. Now, our computer should be able to calculate numbers and store them, but we have a massive problem. We can't see what it is doing. We need a way to display the results. A modern graphics processing, or GPU, is a massive superchip designed to render millions of colorful pixels simultaneously, which is way too complex to create. To display things on our PC, we need to create a super simplified, bare-bones GPU using basic logic components. Instead of a modern monitor, our display screen will be a cheap grid of tiny light-emitting diodes, or LED, arranged in a simple square matrix, which can all cost around $8. To actually make GPU work, we build a dedicated circuit that constantly reads a specific section of our memory. Inside that memory, the CPU stores a map of zeros and ones representing which lights should be turned off or on. Our custom GPU circuit takes those binary numbers, translates them using basic binary binary to decimal decoder chips and sends pulses of electricity down the correct rows and columns of our LED grid to light up the letters or numbers. If the CPU calculates the number 5, the GPU reads the binary pattern for 5 and lights up the LEDs in the shape of a number 5 on our board. By typing a basic instruction into a row of manual toggle switches, our hand-wired CPU should processes it, reads the backup data from our magnetic disk, and writes the correct answer on our glowing LED grid. It will be slow, and I would not be able to play games on it, but it is a fully functioning computer built from scratch. And the cost of this computer? Well, if I counted right, everything should cost less than 90 bucks. And this will be all from me today. Also, if this video hits 1 million likes, I will create full documentary on how I build it in real life.